have covered. Okay, so C chart is count of non-conformities. So where normally we are using, okay, N as one inspected unit. Okay, we also study U chart. Okay, U chart is very useful when we have variable sample size. Variable sample size, U chart is going to be very useful because U is actually as the ratio C over N. Okay, C over N. So these are the formula to get the control limits. And also we have here examples. Okay, in your assignment also you have related question. Okay, almost similar to what we have discussed. So you have to check it, your understanding by doing the assignment. All right, so as I said that in U chart, okay, it is effective for variable sample size. Okay, because normally what we do is because attribute control chart, the inspection is normally 100%, 100%. So there are possibilities that the number of inspection unit in the sample not constant. Okay, they are not constant. So expect, for example, inspection of roll of cloth or paper. Okay, lead to a situation size varies. You inspection kain katakan, okay, inspection paper. So the size of kain panjangnya berbeza. Okay, papers, okay, the boxes maybe dia punya size pun berbeza. So what we do here is 100% inspection, but we assume those are one inspected n equal to one inspected size. Per n equal to 1. Okay, so non-conformities is U chart. Okay, C chart is a situation both center line and control limit will vary with the sample size. Okay, if the control chart non-conformities is used, okay, both center lines are going to be complex lah when there is what we call this the sample size varies. So such a control chart will be very difficult to interpret. Okay, if C chart is used when the sample size is this, okay, it's difficult to use. Okay, so that's why we are assuming that C inspected unit, okay, the number of inspected unit in the sample is usually okay, usually we for the C chart we assume the inspected unit equal to n equal to 1. Okay, one roll, one boxes, one packages, 1 dozen. Okay, that was C chart. So when there is sample varies, so U chart is more suitable. Okay. So we have discussed that. So this is where example of U chart. U chart, you see that this control limit varies. Okay, control limit varies because of we are using this formula. Okay, these are the formula for U chart, central line and control limit, and we have this U bar plus 3 square root of U bar divided by n. So if it varies, this varies. Okay, this n will be varies. So this is what you get it here. Okay, for this U chart, okay, it varies. The control limit varies. Okay. Okay, there is another chart that I have not discussed. This is refers to as demerit. Okay, demerit control chart. Okay, demerit control chart. Why we need demerit? Because the severity of defect is not the same. Okay, severity of defect is not the same, so we can use demerit control chart. for this purpose. The classification of demerits, okay, we can have, for example, very serious, moderately serious, ataupun minor. Okay, so minor. So ni macam we are looking at human health lah, okay, kesihatan seseorang itu. Ada kalanya dia hanya batuk saja, ada kalanya dia memerlukan batuk yang simple ataupun batuk yang serius yang memerlukan makan ubat, ataupun selain daripada batuk, dia demam, dia tak boleh berjalan, dia lebih more serious, tapi semua itu dia kategori yang tidak sihat lah. The same also in we do inspection when we have defects. Okay, we have defects. Ada defect yang sangat serius, tak boleh pakai, dan produk itself tak boleh guna. Ada defects hanya kosmetik sahaja, will be minor. Okay, the minor. So kalau defect according to this author lah, dia kata class A defects, class B defect, class C defect, class D defect. The class A is very serious, so completely unfit for service, tak boleh guna langsung. Okay, itu very serious. Kalau serious, it will be possible to suffer class A operating failure, or will certainly cause somewhat less serious operating problem. Boleh pakai tapi tidak berapa sempurna lah. Moderately serious, okay, it will be possible to fail in service, but less serious than operating failure. Minor is not failing, just to be failure appearance. Okay, I give you example. Contohnya katakan you have a chair. Let's say, okay, let me go to, I think I have empty space somewhere. Okay, let's say you have a chair. This empty space. Okay, you have a chair. You have a chair. Okay, let's say a chair. Looking at the chair there. Okay, so possible defect of the chair, it could be broken leg. Okay, can you use a chair with a broken leg? Is it safe or not? Katakan kaki ni patah. Selamat tak pakai? Selamat?
Tak selamat.
Tak selamat. Boleh menyebabkan jatuh kan? Okay, jatuh mungkin akan dari kecederaan. Okay, what happen katakan belakang ni, back ni ada scratch saja. Mungkin ada calar. Is it okay to use this?
Okay.
Okay, kalau calar saja, mungkin scratch saja. Okay, so dia punya degree of defects tu adalah tak sama. Okay, mungkin ada satu tempat duduk ni mungkin ada lubang saja. Okay, is it okay or not pakai lubang? Ada lubang. Ada hole ya. Is it still safe to use?
Kecil masih selamat.
Masih selamat.
Okay, masih selamat, boleh pakai, tapi mungkin dia kurang selesa kan? Okay, mungkin ada hole. Yang ada hole kecil mungkin okey lah, kalau hole besar bahaya. So jadi itu maksudnya kita katakan dia adalah demerit. Demerit. Okay, you boleh classify pada A ke, ataupun B ke, C ataupun D kategori. Okay, demerit dia berbeza. Okay, so jadi kita boleh kelaskan dia sama ada ia adalah defectnya adalah serious, very serious. Very serious ni maknanya kaki kursi yang patah tadi lah, completely unfit, completely cannot be used. Okay, kalau B, okay, dia possible can cause failure, tapi still boleh pakai lah. Okay, operating failure will certainly cause somewhat less serious operating problem. Will certainly have reduced life. Okay, katakan yang kursi yang berlubang tadi, you boleh pakai, tapi kalau you pakai dan suka goyang-goyang, duduk pun yang badannya saya yang besar, okay, mungkin menyebabkan lama-lama dia mengganggu kestabilan kursi. Finally, it will fail also. Okay, so moderately serious, Okay, dia less, dia degree of seriousness less daripada B lah. Kalau C tadi macam scratch lah, scratch. So ini kita panggil demerit. Jadi all the attribute control chart that we have seen before did not consider this. Okay, katakan C chart tidak mengambil kira aspek ini. P chart tidak mengambil kira, NP chart tidak mengambil kira. They just count everything is one. Either it's just a scratch, either it's a hole, ataupun a broken. They are considering just as the same defects and not according to seriousness of type of defect. Okay, so there is a system that people try to give weightage. Okay, give weightage to the demerit tadi. Class A, Class B, Class C, and Class D. Okay, so that they give, for example, Class A, the weightage given is 100 to show that it's very serious. Kalau Class B bagi 50. Class C, the weightage is 10. D is 1. So weightage here maknanya pemberat lah. Okay, so finally you can get the demerit in the inspector unit is given as 100 C. Okay, 50. Basically, this is a number lah. C is the number of defects. C is the number of defects. P is also number of defects. Sorry, C is number of defect. Okay, kita ada C number of defects yang kategori A. Okay, kategori A. I ini lah depend on the sample size lah, the sample that we use. Okay, so ada CA, okay, count for A, count for B, okay, count for C, okay, count for D. I mean the type of that defect lah, is counting that. Okay, we are counting that. So and then put the weightage here, 100, 50, 10, and 1. Okay, so this weightage are widely used. Not necessarily like this. Some system or some user, they use different. Okay, they use the different. Okay, they are using, for example, okay, in this case, ni they got the demerit weight A, so you can see that in this case, weightage for A was given 100. Weightage for B is given 50. Okay, weightage for C given for 10, weightage for D given 1. So this is not fixed, not fixed. Sometimes people might be using different numbers. Okay, ada sistem yang menggunakan, contohnya they are using 10 here. Okay, they are using maybe here they use maybe 7, okay, maybe 5, maybe 2. Okay. So these are varies. So this just showing the example only. All right. So to get the U, okay, in this demerit, our chart will looks like this. This is the chart for demerit chart. In the demerit chart, we still use U as central line. Okay, for demerit chart. Okay, still have U, and we still have U bar plus 3 sigma of U, and we still have lower control limit, which is minus 3 sigma U. Okay, so we need to know how to get the U. Okay, for central line, this is the how we can get the central line. Is the weighted demerit point. So this central line is the central line calculated. Okay, this we get it from here, which is weighted 100 for very serious, okay, moderately serious, and so on. So the difficult part is how to get this sigma U. Okay, sigma U. Remember that U, like what we have done earlier, U is defects divided by the ratio of defects divided by N, the number that we use in the inspection. Okay, so Okay, in this case dia kata D is summation of DI, the total number of demerits in all inspection unit. Okay, total sample, the total number of demerits. So maknanya basically is just in term of counting ya lah, bilangannya. Okay, bilangan how many. Okay, so the sigma here is given by this formula, okay, which is a square root of, again, this is the weightage, okay, the weightage. For sigma weightage 100 square, maka kita kena square of the weightage. Okay, all the weightage are square. Okay, all the weightage are square. Have three weightage. Ada sistem yang menggunakan hanya 3 sahaja. Okay, dia panggil critical, okay, moderate and minor. Okay, ada tiga class of seriousness. But dalam case in your textbook here, they are using 4. Okay, mana-mana system is okay, but normally we decide the weightage based on case by case and experience of the company lah, experience in the organization. So it could be like try and error juga lah. And then the weightage will be multiplied by the average of category yang very serious, moderately serious, and the minor tadi lah. Okay, mungkin for us to understand this what you can say the serious ni, the way to say is critical lah, critical. Dalam keadaan critical lah, kita tahu critical macam kes COVID lah, kita tanya critical tak? Yes, critical. Okay, dah tak boleh menampas, kena bantuan apa kita kata, bantuan ventilator. Okay, critical lah tu, critical lah, okay, maknanya can cause death lah, kematian. Very serious. Kalau serious tu tak berapa lagi lah, in between this. So this is in between, dan this is minor ni. Okay, so if you can understand that critical, dia menyebabkan penggunaannya terganggu. Dia menyebabkan failure, fatal lah. Okay, catastrophic failure, fatal failure, failure, okay, kemalangan yang serius. Okay, yang lain tu in between, and this is the minor ni adalah, okay, yang appearance saja, masih boleh digunakan. So jadi we use this dalam giving the weightage, okay, to get the central line dan juga the stigma. Okay, so okay, ada juga sistem yang menggunakan 2 sahaja. Yang ada menggunakan 2 sahaja. Kalau 4 tadi mungkin nampak complex and confusing. So many situation, many variation of this is possible, okay, of this demerit. We can classify non-conformity either functional defects ataupun appearance defects saja. Ada yang pakai macam tu, di mana 2 kelas sahaja. Okay, 2 kelas. Seperti yang saya kata tadi, ada yang pakai 3 kelas, ada yang pakai 4 kelas. So ada juga yang pakai 2 kelas saja, di mana dia panggil critical ataupun not critical based on appearance saja. This is easy to implement lah, especially in in practice. The operator maybe have difficulty kalau kita beri banyak sangat kelas, dia nak decide which class. Kalau kita kata okay, you kelaskan yang serious, yang memang functional effect tak boleh pakai, you kelaskan sebagai critical. Okay, the other one is adalah minor, di mana appearance saja. Okay, kalau kita nak lebih more accurate, kita tahu, okay, tambah satu lagi, anything in between critical, okay, dan minor. Okay, kita letak satu lagi yang mana kita tak sure, it's not minor, it's not critical, but in between. Kita letak satu lagi. So this is could be something moderate lah, okay, moderate category. sederhana. Okay. The seriousness is sederhana. Okay, kalau macam tu kita menggunakan sini sebagai A, sebagai B. Okay. Sebagai C lah. Okay. Alright, so let's look at, I think, if you don't have example in your textbook for this one, but anyway, I will try to find example for you to understand better on this. Okay, so the difficulty that you may have is confusion kat sini lah, nak dapatkan sigma kat sini This sigma di sini. Okay, because this sigma U, okay, we get it the averages for different category. Okay, U bar A, actually we have to calculate the average of all the category of A. Okay, U bar B is all category for B. Okay, all category for C, all category for D. Okay, after we get all the average, dan ingat U ini datangnya, what is U? U is coming from, okay, earlier notes dia kata D over N, which is defects divide of N of each category lah, okay, each category. So D, this is actually C lah, count of non-conformity. So don't confuse with this label we are using the same. It's not related to this. So this is basically defects defects, not defective, defects. Is it serious defect or minor defects? Okay. So this is the averages of different category. Okay. And then we calculate, put in the weightage, we get a U. Okay. So in this case, kita gunakan same value ini, tapi we are square, we put a square of the weightage, this square. After that, divide by N. Okay, N is the sample size lah. Okay, sample size. Okay, and then we get the square root. Okay, the square root. Okay, any question up to this point? Saya dapati hanya 38, where is the others? Okay, anyway, any question on this? Okay, saya nak tanya Alvin Ng, when do we use demerit control chart? Okay, no response, but okay, I open this question to everyone. Please put in your chat box. Okay. My question is, when do we use demerit control chart? Oh, okay, I changed my question. Okay. Why we need demerit control chart? Okay, what is limitation of other attribute control chart? Why we need another chart, another type of chart? Why we need demerit control chart? Okay, please respond to chat box. Okay, Muhammad Fitri kata when we have different degree of defects. Okay, correct. Alvin, defective is different degree of class. Okay, correct. When there is different class of defects, is when there are faulty. Yes, they're faulty, but it's different type of faulty. Okay, we cannot just lump sum. Okay, we need to see different category of that. Okay, so we use weightage. Okay, we use weightage, and we multiply that weightage with the average of different category. Okay, different category. Okay, your textbook did not give any example on this, but I tried to find it Okay, from other books I will share with you later on. So maybe that will be clearer. Okay, let me move on. Okay, let me move on to on general aspect of control charting. Okay, in non-manufacturing application, okay, so control chart is not only used in manufacturing but also being used for non-manufacturing. Maknanya, as I mentioned before, it can be used in services like banking. Even a bank, they use control chart to monitor mistakes that is done by their workers. For example, for processing application, how many mistakes the workers have done. Or maybe you want to monitor when they are typing documents. Okay, we can monitor by using attribute control chart. Okay, so it is widely used in service business. Okay, C and U chart. Okay, widely used in transactional and service business. Like for example, banking. I say banking, they are processing document. Okay, how many mistakes they have done? Maybe they have overlooked something while checking forms that have been filled by the clients, for example. Okay. So for example, error in engineering drawing, okay? Maybe you are a manager, you want to check how the technician or draftman do the drawing. You can check, okay? Monitor how many mistakes that the drawing appear in the drawing. Or error on plans or document, error on medical records, error on insurance claims, error on application, error in computer software. So okay, for example, U chart, C chart can be used. Okay, not only in manufacturing. Okay, you might also be wondering how to choose between attribute and variable control chart. Okay, so I think earlier, I think some of you already asked question, how do we select this? Okay, attribute control chart is easier to implement. Variable is more difficult and more costly, okay, because it requires equipment and it require longer time to get the data. Okay. It's even mentioned here, attribute control chart have advantage because it can measure several quality characteristics, can be considered jointly. For example, the D chart, you can consider it a multiple type of defects at once. Okay. But if you are using variable, you are monitoring only one type of parameters only. Okay, so this is expensive and time-consuming. Okay, so expensive and time-consuming measurement may sometimes be avoided, okay, by attribute inspection. Okay, sometimes we want to do measurement on, for example, to see whether product is accepted or not, to measure colors. Okay, whether the color is clear or not clear, we need to buy equipment to measure color. So since it's expensive to get the machine that can give values, maybe kita kata, okay, why not just inspection is done by attribute just to see whether it is clearly printed or is it blur or is it in between. We just make it a simple measurement rather than giving in terms of numbers, how clear it is the print, okay, how blur it is. So since it's expensive, that okay, we just make a measurement using a simple judgment based on attribute, rather than giving specific numbers where you need to measure using equipment. Okay, variable control chart, it gives a lot of information. Actually, a lot of information for us to do the diagnosis of the problem. Okay, so attribute control chart has less information. So these are guidelines to implement the control charting. Okay, what are the guidelines? First, you determine which process characteristic to control. We have to know actually what we want to control. If we possibility that we can monitor. Okay, it's not possible to monitor all the aspect of the product. I give you example earlier, a chair. Why I pick a chair? Because everybody know chairs, very simple. Okay. So where is the critical part of this chair if you want to monitor the chair? Okay, sorry, the drawing is not so nice here. Okay, maybe you have a joining here. What will be critical for a chair? Okay, you have a joint. Okay, you have a joint here, maybe. Okay, you have a cushion and so on. So you can monitor the height of the chair. Okay, when it is assembled. Okay, you can measure the thickness of this back support. Okay, you can monitor the distance between this screw and the other screw. Okay, you can monitor this position. Okay, even you can do the test to see how strong it is, the joining. Okay, there are so many things which are critical to quality. Okay. So how many chart you want to prepare? It could be more than one. Okay, more than one. So one is for the height. Maybe you are monitoring whether the height is proper, the depth, okay, the distance between this screw and this screw, the thickness of the cushion, and maybe you want to put the strength of the leg. Okay, maybe you want to put in strength when you're testing mechanical properties. So many. Okay, so the more we take, of course, more expensive, and we use more resources. So we have to give priority. What is the priority? And also maybe you want to see, okay, the finishing, the painting of the chair. Okay, so determine which process characteristic to control. Because before it become a chair, it goes through different stages in the process. Okay, so what type of chart is more suitable? So it can be confusing, especially for the new person who want to implement this. And then you determine where the chart should be implemented, where to implement the process. You should do it in the cutting process, or it could be in the drilling process, could be the joining, or it could be in the painting. Okay, where it is. Choose the proper type of control chart. Okay, what chart to use? Attribute, or is it whatever? Okay, of course, attribute is cheaper and faster, but less information. Taking action to improve process as a result SPC. Now you need to decide when you do the control charting, okay, what you want to do with this data. Okay, you need to diagnose this data, interpret the data so that we can take corrective action, especially when it's related to examinable cost. Okay, and then you may want to look at computer software, data collection. Okay, do we want to hire inspector to collect data, or you want to buy? Okay, now we have automated system for inspection. Okay, automated system with electronic digital input. For example, to see the height, we may using some digital height measurement, or even you can use some sensing device, okay, that can measure the height. So it become very advanced, okay, for sensing devices. Okay, macam you pergi test COVID lah, ada yang pakai manual, ada yang kita tunjuk muka tu, tunjuk temperature. Okay, these are sensing devices, okay, that can collect data. This data will go to computer system. What we learn now manually, this can be coded in computer, okay, to collect the data and to analyze it. So we need to decide whether what type of data to use and what type of software to use. Okay. Okay, I would like you to read this information. Has very useful information, okay, for us to guide us to implement this SPC, and it is widely used in practice. Okay, either you are implementing control charting in Six Sigma project, or you are using control chart alone without a bigger project. So this is widely used. Okay, so generally the earlier the process control can be established, the implement this early part of the process, because the process go through different stages. If you implement it early, it will be much better, easy to do correction and put remedy lah. Okay, so they should be implement and maintained as close to the work center as possible. Okay, maknanya kalau boleh, this control chart should be the process point, okay? Not at a later stage where it's too late to do any corrective. Okay, microcomputers can speed up the feedback and should be integral part of the modern online. Okay, now we have online SPC. Okay, online SPC, where integrated with data collection, data interpretation, and feedback system to give a corrective action to the process, whether to resetting ataupun to give signal that the process has to be stopped and to be readjust, change the tooling and so on. Okay, we also have guideline to use how to choose proper chart, choosing the proper type of control chart. Okay, when to use X and bar, X bar and R, X bar and S. So this is, we know that it's variable control chart. Okay, so these are some guidelines. Consider using variable control chart in this situation. Process is new. You just set up a production line, so you can use this X bar chart. Okay. The process has been in operation for some time, and there is chronic in trouble and unable to hold tolerance. Okay, we found out that a lot of rejects. Okay, always unhappy customer. So you can use this chart. Okay, so process is in trouble, destructive testing. Okay, so it is always desirable if people like to reduce acceptance sampling or other downstream testing to a minimum when process can be operated in control. When process is in control, actually we don't need to worry about doing a lot of inspection because we are guaranteed that whatever output from stable process will be good. Okay, and also we can switch. Okay, we can switch from attribute control chart, okay, to variable control chart. Okay, number 6 here, attribute control chart has been used, but the process is either out of control or in control, but yield unacceptable. So actually, attribute control chart is easier to implement and cheaper. Maybe you can start with attribute, but after some time, we understand the process, we change it to variables. Okay, of course, variable more expensive, need equipment. Okay. So because of less information from attribute, we change to variable control chart so that we get the patterns, we understand more detail, okay, of the process behavior or process characteristics. There is very tight specification overlapping assembly tolerance or other difficult manufacturing process. So these are some situations that we can use this X bar, R, and X bar and S chart. I want to check your understanding. What is the difference between XR and XS? The chat here. Okay, XR, X bar chart, X bar compared to X bar S. How is it different? Which one is better? What is the difference? Okay. Okay. You can respond. Let me please see the question. Okay, I put this chat box. Okay, you can respond to the chat box. Okay, bagus, dah ada jawab tu. Okay, the question is XR and X bar S chart. Compare which one is better. Okay, Muhammad Fitri kata XS when N greater than 10. Okay, that's good. Okay, S is when N is big. Normally in X bar chart we use only 4 or 5. Okay, but when we have, let's say, we have every sample that we take for every subgroup we take 10 and more. Okay, S chart can be used. Okay. All right, Muhammad Faik are more sensitive than S. Is it correct? Are more sensitive than S? No, not really. S actually is more accurate. S is stand for standard deviation. You take more sample. Don't confuse between comparing X and R. Now we are comparing X and R as a couple. Normally we are measuring both the mean and the dispersion. Okay, X bar is monitoring the mean, R is monitoring the dispersion, which is the range. Okay, the range here can be monitored as, the dispersion can be monitored as range or can be monitored as standard deviation. Okay, dispersion here is referring to how spread lah. Okay, how spread, repeatability. Okay, maknanya it might be accurate but it's not repeatable. Okay, we want it precise and accurate. That's the best lah. Okay, X bar and S are used when sample size variable. Yes, both can be used. X bar and S chart used when the sample size is variable. Yes. Okay. S can use when there is a variable. Of course, you're going to have variable control limits. So basically, the most significant difference is S is for bigger sample size, which is N greater than 10. 10 or greater. So R cannot be used. R also can be used, but R is giving the difference between maximum and minimum. Okay, so as we say that here, this variable control chart is for type specification. Okay, for example, you know that this process require very close monitoring. Okay, use it variable control chart rather than attribute control chart. Okay. So in case of attribute, these are consideration. Attribute control chart, operator control the assignable cost, and is necessary to reduce process fallout. Meaning that you don't use expensive equipment, just operator doing it, maybe visual inspection. The process is a complex assembly operation and product quality is measured in terms of occurrence of non-conformities. It's successful or unsuccessful. Maknanya tak ada measurement lah, just a go and no go saja. Okay. So process control is necessary, but measurement data cannot be obtained. Sometimes it's not possible to obtain the measurement data in terms of specific values for the parameter that we are measuring. So this is the only choice, is use attribute. Historical summary process is necessary, such as P chart, C chart, U chart are very effective in summarizing information. Okay, remember that attribute control chart are generally inferior. Okay, you have to understand this. Attribute charts generally inferior, maknanya tidak sehebat variable. Okay, there has limitation. Information also limited. Always use X bar R or X and R chart whenever possible. Okay, whenever possible, use variable. Okay, unless you cannot use those because of expensive because you want a quick decision, you can use attribute control chart. But in the case of services like banking, the office processes in office to count how many mistakes. Okay, so that is not necessarily to use X bar chart. Maybe not suitable or not needed. Okay, in such cases, so attribute can be the right solution. Okay, also control chart for individual. Okay, we have discussed this also earlier. Okay, when we use the individual, especially when automated inspection, you are monitoring it individual units. Okay, automated inspection testing. Allow measurement of every unit. So we can use control chart for individual. We have learned all this. Okay. Okay, generally, once we are in phase 2, individual chart have a poor performance. If shift detects are very sensitive. Okay. If shift is sensitive, okay, to the normality assumption. Okay, in control chart, we always assume that it's normally distributed, especially for X bar, which is for mean monitoring using X bar chart, X bar S, S bar R. Okay, so but if normalities cannot be met, okay, we can use EWMA QSUM chart. Okay, we have seen this. EWMA QSUM chart can eliminate or minimize the effect of non-normality. Okay, always use EWMA or UMA and QSUM chart in phase 2 instead of individual chart whenever possible. Okay, instead of individual, especially individual shuhat. We have seen earlier that UMA and QSUM is sensitive to small changes. So try to avoid using individual control chart based on SHUART. But instead of using SHUART individual control chart, we use EWMA and QSUM. So these are guidelines because in practice, you might be wondering, which chart to use. Nobody is there to help you to decide. Okay, so this is some of the guideline also related to implementation of control chart. We are monitoring, is the process in control or is it the process is capable? Okay, I think we are time for break now. I continue after the break. Okay, we take 10-minute breaks. Is it okay? Break now? Okay, break. Okay, can we continue?
Yes, Doctor.
Okay, I see only 40 online. So 12 orang lagi duduk mana? 13. Okay, anyway. Let me continue what we left just now. Okay, let me put it back with sharing. Okay, I was sharing here. Okay, and also join this part. Okay, so we were discussing this, the importance of using SPC, okay, how we can take action after using it. Okay, first is we want to make sure the process is back in control. Is the process in control and the process is capable. Process can be in control, but it's not capable. Okay? Control here means statistical control. It is within control, but whether it is capable or not is another one. A process is capable or not, has capability or not. Capability is depending on tolerance that we set. Okay, you still remember, control is determined by the process. Okay, you have a control chart. Is it in control or not? Basically, the simplest way to see the control is to compare with the control limits. Okay, but more on advanced application, we also look at the patterns of the points that we are plotting. The point may be inside the control limit, but the pattern is not normal. So that also indicate the process having problem. Another way to look at it is it capable or not? Is it capable? Okay. So what is capable? Okay, capability is we are using CP, okay, which is equal to what? Okay, I would like to test your understanding. What is capability? CP is what? What is CP? Okay, can you put it on chat box? What is CP? What is CP? Or another way we say is process capability. Okay, you can respond to the chat box. What is CP? Okay, please respond to the chat box. What is CP? Okay, very good, Alvin An. Tolerance divided by process variation. Okay, what is tolerance? What is process variation? Okay, so what is tolerance and what is process variation? Okay, somebody has responded there. Okay, very good. Alvin juga, orang lain tak jawab ni. Kenapa ni? Okay, so tolerance is basically is specification. Okay, specification. So you are putting upper specification minus lower specification, lower control limit. How come control limit and specification? So that's not correct, Alvin. Okay, you make correction there. Upper specification limit minus lower specification limit. That is the tolerance. Okay, what is process variation? Process variation is known as 6 multiplied by sigma. Don't confuse sigma in this capability with the concept of Six Sigma as a methodology for problem solving. Six Sigma in methodology for problem solving has a bigger meaning. Okay, in this case, it's 6 multiplied by sigma. Okay, about others, please respond as well. Okay. So CP is basically tolerance divided by 6 multiplied by sigma. Okay, so now we want to check processing control or not. We are checking using this control chart where you are having upper control limit, lower control limit. But when we say capability, we are comparing the specification, okay? Upper spec minus lower specification limit. Okay, we said divide by 6 multiplied by sigma. Why 6 multiplied by sigma? Actually, this is the range of 6 sigma. Okay, so it is basically, it is control limits. Okay, we are comparing. We are comparing. Another way to say, in a simple way, it is we are comparing tolerance, okay, which is determined by the designer, and 6 sigma, which is determined by the process. Okay, tolerance multiplied by 6 sigma, which is this upper control limit, lower control limit. This is 6 sigma. So this is what we call it by the process variation. Okay, so you want to know whether the tolerance that you have picked is capable or not to be produced. Okay? Is it capable to be produced or not? So now the important thing is in control, yes, in control, but it's not capable, also has a problem. So the matching between the capability and control is very important. Understanding this is the fundamental understanding. So if your specification limit is here, okay, if your specification limit is above the control limit, so there is no problem. Okay, the process is capable, okay, because your specification is bigger than control limit. So remember, specification can be determined by designer, but if he put too big tolerance, the product is no good. Okay, if he put it too tight, it's difficult to produce. So now he has to understand, okay, where to select, okay, where to select this specification. So that's where we use SPC. Okay, to see here, we have 4 quadrants here. If process is in control and is capable, SPC is okay, meaning that it's enough for us to use control chart. Okay, so by process is not in control, but it is process has capability. Yes, you still solve the problem using SPC. But the problem is process is control, but it's not capable. So what you need to do, you need to implement experimental design. Okay, experimental design. So you're going to study design or experiment in another course. Okay, another course, quality engineering, design of experiment, where you will investigate what should be the correct setting. Okay, what should be the correct setting for that process? Okay, maybe the setting that you have chosen is not correct. So you have to look into using design of experiment, okay, to identify the right values for the process. Okay, you may also investigate the specification, okay, because the specification not possible within the capability that you have. Okay, for example, you may have somewhere inside here, this is your specification. So now this is not capable. So you need to investigate the specification, or you need to change the process. So this will be the last decision. Change the process, buy a new process. The situation also becoming worse when the process is not in control and the process also not capable. This is a very big headache lah, very challenging. Okay, dah lah tak control, not capable pula. Okay, so you still use this. Look to design or experiment, investigate, more thorough, and so on. Okay, so those are to guide us lah. Okay, action to improve the process. Okay, as we have seen earlier, SPC method now being integrated, okay, with new technology, okay, for pattern recognition, okay, for diagnosis improvement. Now people are saying that quality 4.0. Okay, we heard about industry 4.0, but in quality, a more focused subset of industry 4.0 is quality 4.0. For those who want to study more on this, you can use this as your group project title on quality 4.0, where automation, internet, sensing are used, okay, in quality. Control chart will not produce very many out of control signal, but usually necessary to intervene activity or process to improve it using design of experiment. Okay, if you don't get enough information, you need to conduct design or experiment to find actually where is the real problem. Okay, so as I mentioned, you may consider looking into the specification to decide, okay, what should be the appropriate specification. Maybe those who are in design, they never study about SPC, they never study about quality system, so you need to advise them. Okay, you have to educate them. Okay, how to decide specification based on the capability that are available in the company. Yeah, capability of machines and equipment available in the company. And as a last resort, you need to consider changing the process, okay, buy new technology and so on. Okay, these are some guide how to select data collection system, computer software. Okay, so of course that SPC traditionally was used manual method, especially in Japan, they use it manually so that the workers can really appreciate and understand what is the process information being demonstrated by this SPC charting. But now, digital equipment for data collection, and of course appropriately that data should be processed by software, the software to assist in implementation of control chart. So what software? There are many software. These are common. Minitab is quite common. Minitab, even your textbook also give example of solution that is generated by Minitab. You can Google Minitab on YouTube, see what are the function and features of Minitabs. Okay, we don't have time to go through this Minitab, and also we are online now. We don't have that facilities. If you are on campus, okay, we can show that this software available in industrial engineering lab. Okay, so Minitab is quite popular to use it to analyze statistical data, to plot the chart, to plot the histogram. Okay, various type of chart is available in the software. So the basic that you learn here is assisting you to select what type of chart, whether you are selecting the right charting. And also another challenge is how to collect data. What interval to use? Is it every 1 hour or every half an hour? And how much sample that is required? So these are some questions that you might be facing when you implement it in real life. Okay, when you want to start collecting, is it start at 8 o'clock? After that, the next sample taken at 8:30 or at 9, or how is it going to be? So that is the decision making that cannot be done by software. Those are the implementation has to be decided by the quality engineer, but the data can be processed by software. But software cannot tell you when to collect. Okay, when to collect, what is the interval? Do you want to collect based on period of time or instant of time, okay, that we have learned earlier. There are different effect, sensitivity of the data of the control charting. If you collect it, let's say this is 8 o'clock, 9 o'clock, okay, you want to collect the sample as it is being produced throughout this. Okay, let's say you select one here, one here, one here, okay, or you are selecting instant time period. For example, you select all the point, all the sample we taken at these instances, okay, at 8, okay, 8 a.m. And the next will be taken at 9 a.m. Okay, we know that sensitivity of the charting is different, different if you collect data like this or collect data like this. Okay, I think that's enough for control charting. Okay, in general, I cover the control charting, variable control chart, and also attribute control charts. Okay, we have many charts. Okay, please do the exercise that I've selected for you to get better understanding on that. If you have any question, you can ask. If not, I will move on to another topics, which is on acceptance sampling. Okay, acceptance sampling. Any question? Okay, any question, anyone? Okay, if no, I will proceed with acceptance sampling. Okay, acceptance sampling, which is very much related to making decision based on samples. Okay, for example, we are buying something. Okay, we are receiving items from vendors. Okay, we are purchasing. For example, in let's say in a business mini market, you buy many things. You buy beras, you buy sugar, you buy biscuits, you buy some fruits, vegetables, and so on. So how do you decide whether to accept or not whatever being delivered by the suppliers? Okay, so you must have a system to make a decision, either to accept what they send to you or to reject, okay, what they have supplied. Of course, it's not possible for you to check every unit because too many, you don't have time. So the system that we use is, we call it acceptance sampling. Okay, I've shared this slide from different books, which is more simpler actually, from Westerfield. I hope that you have seen that in your Telegram. Have you received that in Telegram? Please reply to chat box. I just want to make sure at least one person reply that they have seen this in the chat box. All right, Muhammad. Thank you for replying. Okay, so that's what I want to show now. Acceptance sampling. Acceptance sampling. Okay, if you familiar with what we just discussing here, control charting, acceptance sampling, this will make you easier later on. If you work as a quality engineer in a company, you want to be, for example, expert in Six Sigma. Okay, this is a very useful certification. There are organization and training, company providing Six Sigma training. So you will see this again. So make you, if you get certified, Six Sigma certified, practitioner, so that's very marketable lah. Okay, you can get good job with that certification. Okay, you can Google if you don't not clear what I'm saying. You can go to YouTube, try to search how to get certification in Six Sigma. There are, yellow belt, green belt, black belt. Okay, company are looking for this type of expertise. Not only knowing the theory, but they want to see competence, competency. Okay, getting those type of certification. So if you already have this background, that will make your what do you call this, your certification easier. Okay. If you never study SPC and then we want to take it, so maybe a big challenge lah. Okay, let me put this attribute control chart. Sorry, not contribute control chart. I want to put it sampling, acceptance sampling. Okay, so this is coming from Westerfield. Actually, Westerfield is easier to read, but it, in term of explanation, the textbook that we are using now, Montgomery, has more details, more details. And but anyway, for us to get understanding, I use this. Okay, so okay, what is fun? Okay, do you see what I'm sharing or not? I thought you see. Let me check. Do you see or not?
No, Doctor.
I see. Okay. I thought you have seen. Okay, let me check again for sharing here. Okay, now you see, right? Okay, I go back to the. So this is we call it lot by lot acceptance sampling. Okay, lot by lot acceptance sampling. So this is where we make decision based on sample. Okay, sampling here is by attributes. We already know attributes. We already know what's attribute. Okay. So this sampling that we are discussing is based on attribute. Okay. So on this outline, I just skip. You can go and read on your own the objective and so on. So we need to understand what is acceptance sampling. Okay. Acceptance sampling is a form of inspection applied to lots of batches of items before or after process to judge performance, okay, to determine the standard. Okay, another way is we make decision based on sample. We take sample. Acceptance sampling is useful when large number of items must be processed in a short amount of time. Okay, we have a lot of shipment arrive to our shop, or maybe we are in manufacturing, we receive raw materials. We want to decide to accept or not to accept what has been sent to us. So of course we cannot inspect 100%. It's too much, too many, and we don't have time and expensive. Okay. And also the cost of passing defects is low. The cost of passing defects is low. When the cost of passing, okay, sometimes, okay, we cannot guarantee 100% everything of our product produces in good quality. Okay, because we do inspection also based on sampling, but we allow these some defects to go into market. There's some people who are unlucky, they get the defects one. Okay, you may have experienced this. You buy product, suddenly cannot use. After 2 days, it's broken. Okay, but your friend bought the same thing, but he can use it for a long time. And he can use it for a long time. So why? You got the wrong one because that sample, the inspection is based on sample. You are the unlucky one. Okay, so how to overcome this? So what the company do is, okay, they implement warranty scheme. Okay, warranty scheme, you got a warranty period. Okay, that's why when you buy something, ask for the warranty. Do you have any warranty or not? Okay, let me make it bigger. A warranty period. So sometimes it's given 3 months. 3 months, normally the supplier is not confident that they are good. Okay. Sometimes they are giving 1 year, 2 years. Even now, some product give 5 years. Okay, 5 years. For example, they give warranty 5 years. Okay. For the engine, for example, for refrigerator, the motor is guaranteed for 5 years. So they are meaning that they are very confident the product is good. Okay. So this is when, because why they do the sampling? because one thing is we are able to pass, this defective might be go to market but we cover through warranty lah. Okay, warranty. Okay. So instead of we do the 100% inspection, it is more costly. We say, okay, I will do sampling, but at the same time, I will implement the warranty. A warranty scheme lah, warranty scheme. Warranty scheme. So that's why when you buy a product, okay, you need to use it. Don't keep it for 1 year and then use it, because warranty period is 1 year for many of the products. You buy computer, okay, sayang sangat nak pakai, simpan setahun, lepas tu baru pakai. And then it's broken, the warranty period already finished. Okay, so when you buy new product, especially electronics, use it immediately because it's covered under warranty. Okay, make sure it's covered under warranty lah. So if it's broken within few months, so the early failure, we call it, this is could be due to problem of manufacturing or problem in design, and it is covered under warranty. If it doesn't fail within 1 year, most likely that product will last for many, many years. Okay, for many, many years it will last, maybe for 3 years, 4 years, 5 years. Okay, maybe after 5 years, you can see some component worn out. So that is expected, okay, expected failure. Okay, after 3 years, 5 years, okay, you maybe not doing proper maintenance services, okay, you're going to fail because of worn out. Okay, this is the theory of failure. We're going to see later on in reliability, but for now, I just relate this for you to understand. The failure curve. Okay, we have failure curve like this. Okay, for the chance of fail, okay, we call this bathtub curve. I will cover this again in reliability, failure. So this is the early part of failure. Okay, this is the time, the time. Sometimes people call this bathtub. Okay, so this is, we call it infant failure. Maknanya kegagalan awal lah, infants. Okay, macam kanak-kanak lah. Okay, this is kecacatan kanak-kanak di awal, banyak penyakit. Lahir itu banyak penyakit. The chances dia nak survive for long time maybe lower lah, probability. This is normal failure. The graph showing the failure is lower rate. Okay, unless you use the item in wrong way, the failure will be faster lah. Okay, you're supposed to use the equipment within a controlled temperature, but you use it in a hot temperature, so you're going to fail faster lah. So because not following the operating procedure. The last part here is, we call it worn out. Worn out failure. Okay. Or wear out lah, wear, tear and wear and tear. Okay, wear and tear. Okay, so this part is wear. The house lah, house. Okay, so that's why if you use a car, you need to go for maintenance. Okay, from time to time you need to go for service. Okay, to make sure that the worn out part is being replaced. If you don't replace the component, it will cause the system failure. Okay, the whole car will fail. You change your oil. Okay, so now this is worn out. Okay, so I'm showing here is related reliability and sampling, reliability and sampling. So go back to this acceptance sampling. Okay, acceptance sampling is we want to decide, okay, either to accept or to reject the shipment or product. Okay, so I was deviate a bit here and relate this to reliability, but anyway, it is always related. We have quality, we have reliability, we have maintenance. All these three areas are related. Okay, you have quality, okay, you have reliability, and we have maintenance. Okay, many engineers work as a maintenance. He worked for maintenance of aircon, maintenance of lift, maintenance of M&E systems. Okay, you need to understand this. Okay, maintenance, okay, reliability, okay, quality. Okay, if you have poor quality, of course, a lot of maintenance. You spend a lot of time doing maintenance. Okay, a lot of disturbance. Very stressful. Huh? If you have poor design, you do not know design, you don't consider aspect of reliability in design, you're going to have problem in maintenance. Okay, maintenance. So everywhere you go, there will be maintenance. Okay, okay. So that is the general how you relate different aspect of the field of studies lah. But now we look at acceptance sampling. So this is related to real life. Real life. When you're ordering something, you need to make decision. Okay? And why we do sampling? Because especially in manual inspection, it is boring to do the inspection. Fatigues, kelesuan dan juga boring when the inspection is a large number. So what you do is you do sampling. We do sampling. We take sample. But again, sample can give wrong conclusion. Okay, we may have make decision because of the sample. Luckily, the sample is good. We decide to accept all. But actually, there are so many defects item that we miss out. Okay. And also sampling is useful when for this destructive testing, because you cannot inspect 100%, because when you do inspection, you do testing, that item will be spoiled. And then the only choice is you take sample, okay, so that you don't spoil all the items. Okay, so sampling is useful when inspection is destructive, when you have too many, that can cause boring, and also in fact more mistake. Studies have shown if you do manual inspection 100%, you can have more mistake compared to you take sample, you check it thoroughly, the sample, you have less mistake. So overall, it has advantage for sampling. But less sample, you check it thoroughly. You do 100% inspection using manual, people tend to do it lightly. Dia ambil sambil lewa, semua dia lepas. At the end, okay, the customer will have a lot of complaint. Okay, so this is like acceptance sampling. Like you go to see doctor, okay, the doctor will take sample of your blood, okay, to see whether you have COVID or not. Inject. Okay, they take only few drops of your blood. Okay, a few drops on the blood and then decide you have COVID or no COVID. Yes or no? But people will say, is it acceptable or not? You just take one sample, a few drops. You have a lot of blood in your body. Okay, should you take all the blood in your body and decide yes or no? No, nobody will allow to do that. Okay, you take sample. Okay, you take sample from your body. Let's say just a few sample is extracted and decide. Same thing also, the same analogy we use in manufacturing. We produce a lot of items. Okay, a lot of item you produce, a lot of item. You don't do the inspection for all the item. Okay, so what you do is you take sample of this to represent the whole production. Okay? To represent the whole production, you take sample here, you take sample here, and sample there, sample there, sample there, and you decide. Okay, accept or reject. Okay, to accept or reject, okay, based on sample. So same analogy. Okay, we don't test 100% of our blood in the whole body, but we take only a few drops. Same also in production. You take sample and you decide. Okay, so the question now is how many samples to take? Okay, how many sample to take? Should I take it 2, 3, 5? Okay, and also how should I decide? Okay, if I found only one, should I accept or should I reject? Okay, if I take 10 sample, I found one, should I accept or reject? Or, if I found 5, should I accept or should I reject? So this is how to decide. This can be a dispute between supplier and customer. So there is a relationship between customer and supplier. Supplier, we supply the item, and then now you are the customer. Okay, customer. So you must have agreement before you order something. You have some documentation that you are ordering, and you have to agree with your supplier what system that you want to use in decision making to accept or to reject. You cannot just simply reject. One trailer of material has been delivered to your company. Now you have to accept it. You cannot accept it without inspection. You have to implement inspection. Okay. So how you decide to accept or to reject? If you just simply reject, say I don't want to accept this shipment because it's no good. Okay, supplier will query, okay, what is your decision making? What sample you have taken? How many sample you have decided? Okay, do we agree this in the purchasing document? Okay, so some engineers even work in procurement. Sometimes we call it procurement. Okay, let's say you work in automotive industry, you procure some of the component and parts maybe from China. Okay, you don't produce all the components. Some of the components you purchase, and then you need to decide to accept or not. Okay, from the procurement department, you buy some, item, maybe some motors, some cables, screws, nuts. You don't produce those. Those are standard items that others can produce. So you need to decide when you do this. Okay. So even as engineer, you may be working as a department to make a procurement or buying components. Okay, so you may buy from China, buy from Thailand, and so on. Okay, so knowledge of acceptance sampling is very important. Okay, to guide you in making decision. Okay, 3 important aspects of sampling. So it must involve random sampling. Okay, we must know how to implement random sampling. We must know decision making, accept or reject. This is what you call it lot sentencing. Okay, acceptance sampling do not improve quality, but it's basically for decision making. Improving quality is done through monitoring using control charting. Okay, where you know the diagnosis, you know the patterns, you go to the process, you improve it. But acceptance sampling is not for improving; it's basically for decision making. Okay. So it also can be used as auditing tools, okay? The tool that we audit. So not only you can be used for receiving shipment from suppliers, but we'll also use acceptance sampling for auditing tools, okay? For auditing tools, even from one department to another department. One department say it is a cutting department. Before cutting, after the cutting process finish, you want to send it to the next department, which is maybe assembly department. So the assembly department may want to check what you send is good parts, properly cutted. Okay, so you can use also acceptance sampling for this purpose of accepting what is being delivered by previous department. So internally in the company also can be used. Externally, receiving from supplier also can use acceptance sampling. So 3 approach of lot sentencing. Lot sentencing here meaning that making decision accept or reject. You accept with no inspection, which is not recommended. This is unless you are trusted that the supplier is a good supplier, you can accept it without any inspection. Or you do it 100% inspection, which is very costly. Okay, this is costly and not practical. Unless you are dealing with an expensive item. For example, you are buying some chips, have a gold plated. That one you have to do 100% inspection. Okay, but for general item, 100% inspection is expensive. Okay, if you are dealing with jewelries, you have to do 100% inspection. Don't do it sampling, even you study sampling here, because if you are being cheated by the supplier, not genuine, gold rings, bracelet, and so on, you're going to get in trouble. The under inspection is for expensive item still necessary. Okay, but for general item like automotive component parts, okay, you can do it acceptance sampling. Okay, there are many advantages. I think it's quite general, less expensive, reduce damage, reduce inspection error. Okay, what are disadvantages? This is the risk here. The risk is accepting bad lots and rejecting the good one. Okay, when you accept bad lot, or you are doing sampling, but suddenly you accept it, but actually there are a lot of bad units in that lots that has been delivered. So this is, we call it type 2 error. Okay, type 2 error, which is you miss to detect. Okay, in statistics, in SPC, we call it type 2 error. Okay, type 2 error. It is actually more serious. Type 2 error is more serious because you allow that bad item to go into the customer. Rejecting good lots, this is, we call it type 1 error. Okay, type 1 error, this is like false alarm. Type 1 error. Okay, maybe you have been to offices, building, to UTM. Sometimes you get fire alarm ringing. Actually, there is nothing happened, but maybe the false alarm is being triggered. So this is where the situation has no problem, but it seems that somebody has pressed the fire alarm, so fire alarm is ringing. So this one is not as serious as when you have error. When you have error, but you are not able to detect. Okay, this false alarm. Okay, macam COVID jugalah. Okay, you have COVID, and then you go to check to see the doctor say, okay, you are negative, no COVID, but next day pass away. Okay, so this might be happening because of new variants. You are not able to detect. Unable to detect error is dangerous. Okay, because you can get unexpected death. Okay, so but sometimes you are healthy, but you go to see the doctor and do PCR tests. They say that, oh, you have COVID. So there might be error there, error in testing, but actually you are healthy. That one is not serious because this is just false alarm only. I hope you understand that. Okay, and then it's less information generated and require planning for documentation. Okay, less information generated, require planning and documentation. Okay, so these are disadvantage and disadvantage and advantages of acceptance sampling. Okay, sampling plan. We have sampling plan. We call it single sampling. We have double sampling and multiple sampling. Okay, so you are producing this in the factory, lot by lot. Now you randomly select the sample and you make decision making. Okay, so how to do the sampling? Can do single sampling, double sampling, or multiple sampling. So what are the difference among this? Okay, single sampling, it's very simple. Let's say you produce n lot. Okay, you are producing, let's say you are producing 9,000 units. This is total production. Okay, and you say, okay, I don't want to check 9,000, I want to take sample. Maybe I take 50 sample. Okay, n equal to 50. And acceptance number, say, okay, if I found defects, if I found defective units, okay, I found defective units, okay, greater than or equal to 10, okay, so I will accept. Okay. So if I found defective Unix, okay, defective Unix. Oh, sorry, this is wrong. Okay, I should say this is less than. Okay, less than. Defective unit is less than 10, I accept. So I have more than 10, I will reject. So this is example of single sampling. Based on single sampling, you make decision. Okay, you make decision based on single sampling. If C or less than conforming unit are found, then the lot is accepted. Okay, else is rejected. So this is only one sample taken. Okay, just imagine you take only 50 out of 9,000. Okay, and the issue now is who decide this is 10? Is it you or supplier? Is there a system to assist to do that? Yes, there is a system to guide us to decide how many, the lot size, how many, and how many decision criteria for acceptance number. Okay, we have okay, single sampling plan. Single sampling plan is one where a representative sample, I think I have explained this. Okay. We have double sampling. Double sampling is what we do is we are not able to make decision. We are not able to make decision. So require us to take second sampling. Okay. Require us to take second sampling. So double sampling allow to take second sample. Okay. If result of original sample are inconclusive. Okay. So we take second chance. We are not able to make conclusion accept or reject, but now we have to take second sample. Okay, specify the lot size of the initial sample, the accept, reject, inconclusive region, okay, for the initial sample, and specify the size of second sample. Okay, so after second sample, we must decide accept or reject. Okay, example here. You take from the lot, you take the first sample. Okay, so because it's not clear to accept or reject, you need to take second sample. If it is clear accept, no need to go to second sample. But if it is clear reject, okay, also no need to go for second sampling. Second sampling only when that is inconclusive, meaning that you cannot decide to accept or reject. C1 here, meaning that acceptance number based on first sample. R1 here referring to reject number. Okay, reject number after first sampling. For example, you may have the lot size of equal to 9,000. Okay, you take sample of n equal to 50. Okay, maybe your accept number is 2. Your reject number is 4. Okay, what happens if you get 3? If you get 3 defects, you must take second sample. Okay, because it's inclusive. You can accept or you cannot reject. Okay, of course, we cannot expect 0 to accept because we know that no process is perfect. Okay, so somehow we can tolerate, okay, passing some defect to the customer, but we cover it through warranty. I hope that that one you get some understanding. So when we go to second sample, decision must be made. Okay, either to accept or reject. No more inconclusive. Okay, no more inconclusive when you go to second sampling. You just either to accept or reject in second sampling. All right, I think the time is up. So I would like to open for any question if you have any. If there is no question, we can stop here. Okay, can somebody help me to summarize what you learned today? Within 1 or 2 minutes. Okay, you can put in chat box. That will give opportunity to everyone to answer what you have learned today. Okay, please put the keywords in the chat box so that we can just refresh again for the last 2 hours. Okay, Dim Richard. Okay, thank you. Muhammad Sikri, singer and double sampling. Muhammad. Okay, no problem. Okay. Okay, what else? Process variation. Okay, good. Okay, Azmin, how to choose suitable control chart. Okay, good. Okay. What else? Attribute versus variable control chart. Difference between XR and XS chart. Okay, Jacob. Okay, good. Okay, classes of defects. Okay, which is Dimrit. So Iqbal Putra. Okay, very good. We have class A, class B, class C. Okay, apa lagi? Please recall. The more you recall, is actually is more understanding. Okay, because process capability. From what I notice, for many years teaching, most students will forget what they learn, okay, without doing the recalling. So you need to recall. Those who are apa ni, kalau hafal Quran dia panggil murajaah lah. They have to do a lot of murajaah to transfer short-term memory to long-term memory. Okay, so you need to do murajaah jugalah untuk belajar ni. Always recall, always refresh. Sometimes revision just take 5 to 10 minutes to recall what you have learned for the last 1 hour or 2 hours. Okay, that will help you to transfer your understanding from short term to long term. Ada student juga saya tanya, apa yang belajar kelas lepas, semua dah tak ingat. Sebab apa? They never recall. They never refresh again. You need to recall to reorganize your understanding in your long-term memory. Okay, I think that's enough for now. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.